describe yourself. Okay, so I was just telling Jeremy, we're going to try to do about 6 minutes. You'll hear a timer. You have 2 more minutes to wrap up and do a little Q&A with the audience. Okay? So Jeremy Snyder, thank you so much for your flexibility. Jeremy was part of the group that got bumped for next week's talks. Jeremy is a photographer, digital artist, and science communicator who's keenly interested in how science provides a lens to see the world around us differently. He calls this idea his science X-ray vision, which I love. He uses his work to explain and advocate for the natural world and has worked at Berkeley Lab with the K-12 STEM education team. I'm so excited to hear more about this work. I think it's just absolutely stunning. So, Jeremy, thanks for being here.
Wonderful. Do I just launch right into it?
Yeah, launch into it.
Cool. Hi, everyone. I'm Jeremy. This set of 4 images are all direct overhead drone images, and the kind of conceptual through thread of them is basically how river sediments shape ecosystems and landscapes in ways that are really impactful and ultimately important, but are not always evident from ground level or even human timescales. I kind of came to be really interested in this idea and fall in love with sediments and rivers as a concept because I have a background in biology and geology, which I kind of came to love separately and then realized that they intersect really beautifully with each other and one of my third loves, which is river systems, in this sediment transportation and creation system that really runs the natural world in ways that are pretty amazing. So the sediment cycle, kind of the process by which sand is created and transported all over Earth's surface, is really one of the main venues in which the biosphere and geosphere interact. So it's a place where the world of rocks really influences the world of living things, and actually the world of living things actually influences the rocks back. This happens in a lot of different ways, but some of the really basic ones are that plants in particular have a really substantial role in helping break down rock matter. So the roots and the acids that they excrete to extract nutrients from soils have a big role in kind of working their way into cracks, and they ultimately have a kind of a starting role in breaking down rocks. And then the maybe more interesting and more impactful one is in the other direction, which is that the vitamins and minerals that all of life on Earth requires to survive are ultimately derived, or at least the mineral half, are ultimately derived from this creation of sediments. So minerals being iron, phosphorus, zinc, calcium, potassium, all of the things that you see on the nutrition label come directly from the interaction of water and rock, and with water acting as a weak acid that dissolves minerals out of rock. And that really only happens at a useful scale when that rock is broken down into this immensely high surface area material, which is sand. So the creation and transportation of sand around the world by rivers is really the creation and transportation of mineral nutrients that every living thing requires, and none of us would be here without this process. So with that in mind, and I guess just the more classic role of sand of just literally building up landscapes in the ground beneath our feet, all of these pictures kind of depict certain steps along the way. So this bottom left picture is an overhead of the Amazon River intersecting with a clear lowland tributary. And the Amazon, as your mental image probably carries, is a very muddy river. It carries an immense amount of sediment that's taken all from the Andes Mountains at its headwaters. And that is really thrown into high relief when it collides with clear rivers. And you can see, in a way that you can't, there's just an opaque brown river, you can see the magnitude of the rock material that it's carrying. And that rock material really directly fertilizes the Amazon ecosystem and makes it possible. Then this next image is from a kind of a different context up in the Colorado Rocky Mountains. And this is kind of, I guess, what happens when those sediments are kind of paused along their journey. These meandering river bends happen in rivers that have like a really shallow gradient, and so and rivers that have a lot of sediments in them, so they're constantly kind of pushing themselves out of their own riverbed as they settle, if they drop sediments. But they meander across these rich flood meadows, and things like beavers, which you can see some of these beaver dams cutting across the river there, help push them out of their channel, and they create these really lush ecosystems at the bottoms of valleys. And that's all like a process of sediment transportation, and ultimately the richness of those ecosystems is really inherently linked to just like the creation and movement of sand. And then these second two images are kind of linked more to one of the interplays between biology and rivers, which is that the living thing that influences rivers by far the most is humans. And so both of these are actually the product of what happens when humans dam rivers, which has a really impactful role on this whole sediment transportation regime, because the main thing that moves sand in a river is the momentum of the water, and when you dam a river, that momentum stops, and so all of the sand and all of the sediment settles out to the bottom of the reservoir. So you get these really interesting. This is an image from Lake Mead in Nevada, which is behind the Hoover Dam in the Colorado River. Colorado River, like the Amazon, is historically, naturally, one of the most muddy, like silt, mud, sand-clogged rivers in the world, and yet this lake that is filled by the Colorado River is completely clear. And that's because all of that sediment has settled out onto the bottom of that lake. And so you're left with this kind of supernatural, weird green lake in the middle of the desert that creates these really unusual landscapes. And then this other image is that the 6 minute?
That's 6
Perfect.
minutes.
Okay, I'll finish this really fast then. This other image is actually like the product of that. So this is an overhead of an emptied lake reservoir, again in Colorado, but where the lake has been drained away, or is at a really low level. You can see all of the sediments that have settled out of that river, and they're actually beginning to be carved through again by the stream that deposited them there in the first place. So yeah, I think it's a lot of these things are hard to see or understand or just conceptualize if you don't get these kind of different perspectives that aerial photography can bring. So that's my tie-in to Scott. But yeah, but any questions? Or...
So you went to these areas specifically, like were you like doing other things besides taking photos? I'm curious if
Yeah, yes. I mean, broadly, I think all of these images were taken on trips that were primarily motivated by photography, or I think my kind of specific brand of photography and art is like very intertwined with like photos as a link into a scientific story. So both I guess this image from the Amazon was part of this fellowship that I got after college to explore this idea of like photography for communicating river science. The rest of these were all taken as kind of my own personal follow-up to that, still kind of linked to that same trip. Is that the 2 minute timer?
that's 2 minutes
Well, I tried.